Good morning, Ananda. Today I am hereby to give a presentation on concept of aerodynamic, hydrodynamic, and thermal boundary layer. Before getting into topic, I will supposed to give a small overview about this presentation, which means I will supposed to overview what we are going to discuss in this presentation. So the first is, so initially I will supposed to give a small introduction myself, and then follow on, and the follower we will discuss about the abstract, and then after completion of abstract we're supposed to discuss about the introduction, and then we will get into our main topic, that is hydrodynamic and thermal boundary layer. And at the last of this topic and then by the end of this confirmation, and we will discuss about the conclusion side, in which we can able to recap again what we are discussing in this slide. So before getting delay, I will give a small introduction myself. My name is G San Reddy, having a pin number of 21944A2109, and my topic is concept of hydrodynamic and thermal boundary layer, and it belongs to a course name of heat and mass transfer. So let us discuss about the abstract. In this presentation, we're going to discuss concepts of hydrodynamic and thermal boundary layer, along with some fundamentals for better understanding. Introduction. Before getting delay into, now let us get into topic by quickly starting about the introduction. Hang on a minute. I will adjust my camera. Okay, that's it. Next, now get into the topic. Before getting into the topic, we should come across some information about boundary layer and the formation for a better understanding of hydrodynamic and thermal boundary layer. So without getting delay, let us discuss boundary layers and the formation. So now in order to understand this concept, we are supposed to know the basic definition of a boundary layer. A boundary layer is defined as when there is a relative motion between a fluid and a solid, a boundary layer is formed. This is a basic definition of a boundary layer, in which it describes it is a boundary layer which is formed as a result when the motion of fluid and a solid of boundary is formed, which means to understand in detail, let us consider a flat plate like this, which is placed like this, and then whenever it is constantly stationary, whenever a flow or a fluid is flowing against to it, then as a result the motion in between the fluid and this flat plate tends to form a slight like layer, which is known as a boundary layer. The boundary layer can be defined as an imaginary layer of fluid that is formed when the solid and the fluid are in relative motion. It's a layer where the velocity of the fluid is equal to 99% of free stream velocity. So this is a figure of the boundary layer over a flat plate and the different types of regimes. So in this we can able to understand here. So in this we can able to understand this. Whenever a boundary layer is typically a boundary layer is defined or is classified into three types depending upon the flow parameter. First, laminar boundary layer, in which when the Reynolds number of the flow is less than 5 into 10 to the power of 5, then the flow is treated as laminar. If whenever the Reynolds number of the flow is tends to greater than 5 into 10 to the power of 7, then it is known as, or it is treated as turbulent boundary layer. Whenever the Reynolds number is exactly at 5 into 10 to the power of 5 to 5 into 10 to the power of 7, then it is known as transition region, which means the flow is at the verge of separation, or the flow is verge of transferring the flow parameters to laminar to turbulent, or from turbulent to laminar. Next, formation of boundary layer. When a fluid flow over a flat over the surface, irrespectively of whether the flow is laminar to turbulent, the fluid particle adjacent to a solid surface will always stick to it, and their velocity at the solid surface will be 0 because of the viscosity of the fluid due to the shearing action of one fluid layer over the adjacent layer moving at a faster rate. There would be a velocity gradient in the direction normal to the flow. Let us consider a two-dimensional flow of a real fluid about a solid. As shown in figure 2.2, detailed investigation has revealed that the velocity of the fluid flow detailed investigation has revealed that the velocity of the fluid, particularly at the surface of solid, is 0. The transition from 0 velocity at the surface of the solid to the free stream velocity at some distance away from the solid surface in the v direction, normally to the direction of flow, takes place in a very thin layer called the momentum or hydrodynamic boundary layer. The flow field can thus be divided into two regions: formation of boundary layer and a thin. The number one point is a very thin layer in the vicinity of the body where a velocity gradient normal to the direction of flow exists. The velocity gradient du by dy became large in this section region. Even a very small viscosity m of the fluid exerts a substantial influence, and the shearing stress T is equal to m du by dy may assume large values. The thickness of the boundary layer is very small and decreases with decreasing viscosity. In the remaining regions, no such large velocity gradients exist, and the influence of viscosity is unimportant. The flow can be considered frictionless and potential. Now let us discuss about the thermal boundary layer. Since the heat transfer by convection involves the motion of fluid particles, we must superimpose the temperature field on the physical motion of fluid, and the two fields are bound to interact. It is eventually evident that the temperature distribution around a hot body in the fluid stream will often have the same characters as a velocity distribution in the boundary layer flow. When a heated solid body is placed in the fluid stream, the temperature of the fluid stream will also vary within a thin layer in the immediate neighborhood of the solid body. The variation in temperature of the fluid stream also takes place in the thin layer in the neighborhood of the body and is termed the thermal boundary layer. Figure shows the temperature profiles inside a thermal boundary layer. This is the figure which shows hang on a minute, I will supposed to show the image. So in this image we can able to understand the thermal boundary layer. Now let us discuss about the hydrodynamic boundary layer, because our main concept is about the thermal boundary layer and hydrodynamic boundary layer. So in the previous lectures we have discussed about the thermal boundary layer. So without getting delay, now let us discuss the hydrodynamic boundary layer. One of the most important concepts in understanding that external flow is a boundary layer development. The hydrodynamic boundary layer formation is symbolized before starting the presentation. We have discussed the formation of a boundary layer. It is generally a simple formation of a boundary layer is treated as a hydrodynamic boundary layer, where the boundary layer is usually very thin. Next, and the velocity reaches at the 19% of free stream velocity, and as we have seen earlier, the hydrodynamic boundary layer is a region of a fluid flow near a solid surface where the flow parameters are directly influenced by viscous force from the surface walls. The thermal boundary layer is a region of fluid flow near a solid surface where the fluid temperatures are directly influenced by heating or cooling after the surface walls. Hydrodynamic boundary layer. The two boundary layers may be expected to have a similar characteristic but do not normally coincide. Liquid metals tend to conduct heat from the wall easily, and the temperature changes are observed well outside the dynamic boundary layer. Other materials tend to show velocity changes well outside the thermal layer. So, conclusion: the boundary layer can be defined as an imaginary boundary layer that is formed when solid and the fluid are in relative motion at a layer where the velocity of the fluid is equal to 99% of free stream velocity. The hydrodynamic boundary layer is a region of the fluid flow near a solid surface where the flow patterns are directly influenced by viscous drag from the surface wall. And the thermal boundary layer is a region of a fluid flow near a solid surface where the fluid temperatures are directly influenced by heating or cooling from the surface walls. Thank you.